Alright, hello everyone. I'm doing this video real quick to go over sigma notation again. I'm going to use the same problems from class and also going to use a separate quote-unquote data set just to really drive the point home. So in class, the first time our data set was x equals 1, 2, 3, 4. I'm also going to do x equals 2, 4, 6, 8 as another example. Let's see, so for sum of x squared, so let's put our data set in a column, 1, 2, 3, 4. This is x. I'll put these all in a little box. That's x. Now if you want x squared, then you take each of these, 1 caret 2, do that for all of them. So we got 1 squared, 2 squared, 3 squared, 4 squared in this column, x squared. And to sum that all up, I'll just put sum right here, and that's going to be everything together. 1 plus 4 plus 9 plus 16, that gives you 30. If you want to stop and make sure that you can replicate this with the other data set, go ahead and hit pause, but I'll just go ahead and get that started here. We've got a column 2, 4, 6, 8. That is our original data. Then we have x squared, and it's going to be equals u caret 2, so that's 2 squared. I do that for all of them. So 4 squared is 16, 6 squared is 36, 8 squared is 64. And now that we have all the squared numbers, you sum them as you go. So that comes out to 4 plus 16, so on and so forth. That's 120. So the sum of the squares for this data set equals 30, and for this data set equals 120. And if you're not doing this in Excel, you're basically just doing 1 squared plus 2 squared plus 3 squared plus 4 squared. That's what we have here, 1, 4, 9, and 16. We just add those up. Here it's 2 squared plus 4 squared plus 6 squared plus 8 squared. That comes out to 4 plus 16 plus 36 plus 64. That's where you get the 120 from. So that was the first equation. For the second one, things are slightly different. We're not squaring each member of the data set and then adding them as we go. We're first adding them all together and then squaring the result. So for the first data set, 1, 2, 3, 4, we don't square them. We just go straight to adding them. Well, let me name this sum. So we're just summing the x's. 1 plus 2 plus 3 plus 4 comes out 10. So that's what sum of x is, but then we have to square it. So I'm going to say this is equal to u squared. 10 times 10 is 100. Because we're just adding up each member of the data set and then squaring it. Whereas here, you're squaring them first before you add each squared member together. So for this one, sum it first. I'll label this sum. So that's 20. 2 plus 4 plus 6 plus 8 is 20. And then we're going to square it. That is 20 times 20, or 20 caret 2. That gets 400. If you have been paying attention and following along, you'll know that this is going to equal 0, no matter what the data set says. But let's go ahead and calculate it anyway. So x equals 1 plus 2 plus 3 plus 4. So x of I just means for each member of the set, when I equals 1, that's the first data point. I equals 2, that's the second data point. In this data set, I equals 1, the first member is 2. When I equals 2, the next member is 4. I equals 3, that's the third data point, that's 6. I equals 4 gets you to the fourth member of the set, that's 8. So the x of I just means for each member of the set I. Like I said in class, though, it's not terribly important. You actually could remove the I for now. I'm kind of overcomplicating things by putting it in there. What we're going to do for each member of the set is we're going to subtract the mean. So this will be x minus x bar. Yeah, I'll leave it like that. The mean, if you recall, we already calculated the mean a bunch of times, but let's just go ahead and say mean over here equals average. It's 2.5. You could also say sum of this divided by 4 gets to the same thing, or you could work it out by hand. So if we want, let's just say x minus x bar, not x equals x bar. So for each of these, we're going to say I want u minus 2.5. So the first data point, 1 minus 2.5 is negative 1.5. And we just repeat that for every member of the data set. Negative 1.5, negative 0.5, positive 0.5, and positive 1.5. So that's just for each iteration through each member of the data set. We're just taking the difference between each data point and the mean. That's what this gets us here, but we're supposed to add them up. That's what the sigma means. So we'll say sum of x minus x bar, and just add these babies up right here. That equals 0. Now the average for this data set, let's see, mean, let's say average. So the average for this data set is 5. So I'm going to want to do for x minus x bar, I'm going to want to take each data point and subtract 5. So I want u minus 5. 2 minus 5 is negative 3. Do that for, Excel thinks this is part of the data set, so let's delete that. So we subtracted the mean, which is 5, from each data point. We ended up with negative 3, negative 1, positive 3. That adds up to 0. And actually, anytime you sum the deviations, and that's what this is the distance between each data point and the mean. It's the same thing as saying the deviations. Anytime you add up the raw deviations, you're going to get 0. Sum of x minus x bar equals sum, drag this, that's 0. Yeah, this one tricked some people up, I guess. I think it was more the later ones that tricked people up. So for this one, for each data point, xi, you subtract the mean squared. So the mean is ordinarily 2.5. So the mean squared would be 2.5 caret 2. Oop, I did something wrong. Oh. I actually said 2.5. So it's cell B35 caret 2. That's 6.25. Tripping myself up here. So the deviation, we're doing the deviations not from the mean, but from the mean squared. So we're going to do U, cell D33 minus 6.25. Rinse and repeat. You subtract 6.25 from each value. Oops. You're going to get these values, negative 5.25, negative 4.25, so on and so forth. So this is iterating over each member of the data set. It's just subtracting the mean squared from each one. The summation means you have to add all these iterations together. So this is x minus x bar squared, and this is sum of x minus x bar squared equals these together, comes out to negative 15. For our second data set, we're taking the distance between each data point and the squared mean. So 5 squared is 25, so we're going to subtract 25 from each of these. Minus 25. You get a bunch of negative numbers, and so this is x minus x bar squared, and then we sum them together, sum of x minus x bar squared. Add these all together. There you go, negative 80. Now, this one's actually relevant. This is the sum of squares. This is part of the actual calculation for the standard deviation. You're basically taking the deviations and squaring them as you go. That way you're tricking them into not adding up to 0 every time, because if you don't, you're going to always add up to 0. No matter what these data, no matter what x is, you put any set of numbers in there. If you just add the raw deviations, they're always going to add up to 0. So squaring them is a way to try and get around that and get a useful number. So this is x minus x bar. So this is going to be equal 1 minus, was it 2.5 minus 2.5? X minus x bar. But now, since the squared is on the outside, that means we're squaring the deviations each time. So we're doing 1 minus the mean and squaring that difference. 2 minus the mean, squaring that difference. 3 minus the mean, squaring that difference. And you're adding these together as you go. That's what the sigma means. Add each of these iterations together. So we're going to have a new one that says x minus x bar. Outside parentheses, caret 2 means we're squaring it. So I'm going to say u caret squared. Rinse and repeat. So now we have negative 1.5 squared is 2.25. Negative 0.5 squared is positive 0.25. You see how we ended up with only positive numbers. So now when you do sum of x minus x bar, well, that's going to get complicated representing it this way. Is that right? Sum everything in the square brackets. Yeah. I don't know if that was really necessary. Whatever. Sum up all these squared deviations, and we get 5. Now for this other data set, again, we're just squaring each deviation from the mean and adding them as we go. So it's going to be 2 minus the mean, square that deviation, plus 4 minus the mean, squared, so the whole thing, 6 minus the mean, squared, and you're just adding and adding and adding. So what's the mean here again? The mean is 5. So we're going to do u minus 5. Repeat that for each data point. This is x minus x bar. Then we're going to square x minus x bar. Square each of those deviations. So negative 3 squared. Oops. Negative 3 squared. Negative 1 squared, 1 squared, 3 squared. Now we force them all to be positive, and we're going to add up the sum of x minus x bar squared equals, boom. Sum of squares for 1, 2, 3, 4 is 5. Sum of squares for 2, 4, 6, 8 is 20. So if you were to calculate the standard deviation, this would be pretty much half the battle for each data set. You calculate the sum of squared deviations. Bonus fact, if you want the standard deviation, it's the sum of squares sum of squares divided by n if it's population, but it's the square root of sum of squares divided by n. So that would be square root of sum of squares equals 5 divided by 4. If this was a sample, we'd do divided by degrees of freedom. That's 1.11. So the mean here is 2.5 with a standard deviation of 1.11. You could also say stdev. Well, wait. St and square root of sum of squares divided by n is the same thing. And if I use the function stdev on the raw data, it should, ooh, it's different. What did I do wrong? Oh, I think I know what I did wrong. stdev point p. There we go. When you use stdev, it assumes by default that you want the sample, so it divided by 3, but I was doing the population divided by 4, so you got different answers. Here we got a sum of, we want square root of the sum of squares divided by 4. So that's this same value right here. That's the same thing as the standard deviation. stdev point p. Do that on the raw data. You could skip a bunch of steps, but we also want to understand what's going on. In class today, this was one of my many blunders. I had this baby right here when I really should have had something like this. What's going on here is I want you to sum the deviations and then square that sum once the sum has been summed. It's kind of like the difference between these equations right here. You sum x and then square the sum of x. Whereas here, you are adding up x squared. So you're actually squaring them as you go, and each iteration is squared before you add them together. Whereas here, you don't really do anything as you iterate through the series. You just add them all up as they are, and then you square them. So I was trying to capture an analogy between these two and the deviations that you square. Basically, it's going to end up being 0 squared for each one. So, see, we got x, and we want x minus x bar. Recall that the mean here is 2.5, so there's going to be 1 minus 2.5. Do that for each data point. So now that you've iterated through the data set and calculated x minus x bar, you add those together. So we got sum of x minus x bar. Sum it up. That's going to be 0, of course. Raw deviations always add up to 0. And then you, over here, we got the sum of x minus x bar, and then we're going to square. This is to avoid ambiguity. Let me put square brackets around this whole thing. And we're going to square the whole thing afterwards. 0 squared is 0. And the same thing will happen with this other data set. X minus x bar is each data point minus the mean. What was the mean for this again? 5? Yeah, 5. So each data point minus 5. And it doesn't tell you to square them as you go. You're just adding up the raw deviations without squaring anything. So we got sum of x minus x bar. Comes out to 0. I'm not going to write out that whole other thing. 0 squared equals 0. That was the intended lesson, is that I wanted y'all to know the deviations is, a deviation is just the distance between the data point and the mean. And I wanted you to remember that adding up the raw deviations is always going to equal 0. And it really matters where you put this exponential, the squared. If it's directly outside, this is kind of where things got shaky. If it's directly outside the deviation, that means you square the deviations and you're adding the squared deviations in turn. Each deviation squared is added together. Whereas in this one, you're not squaring the deviations, you're just summing them. So you got deviation number 1 is negative 1.5, deviation number 2 is negative 0.5, deviation 3 is 0.5, deviation 4 is 1.5, meaning that the last data point is 1.5 units above the mean. And this just says just to add them up. Add up all the x minus x bar. That's always going to equal 0. And I was trying to show, like, yeah, if it adds up to 0, you square it, you get 0. All right, I hope this helped, and I will post this ASAP.